Welcome, my dear learners. In this session, we shall be looking at another type of questions under trigonometric functions. Given the function sine ax, cos ax, tan ax, and their reciprocal angles, then we can find the derivative of these each individual's trig functions using the chain rule. And we have already learned about the chain rule. If you have forgotten, kindly go back and then watch my previous video. Okay. So if you have the function capital F at x, which is equal to sine ax, then you can see that the derivative of this function capital F at x using the chain rule is going to be given as f prime at g at x multiplying the derivative of what? G at x. And we know that f at g at x is the outside function and then g at x is the inside function. So let's take example and then see how best we can apply them. So to find the derivative of this function, we can apply the chain rule. So we first have to identify our outside function and then our inside function. So we let our f at g at x be equal to the outside function, and that is what? Sine. So we have sine 3x, and then we let g represent the inside function. The inside function is what? 3x. And then we find the derivative of f at g at x, which means that when we differentiate sine, what are we getting? When we differentiate sine, we get what? Cos. Then we add our 3x, and then we find the derivative of g at x, and that is going to give us what? G prime at x. So when we differentiate 3x, we are getting what? 3. So we know our f prime at g at x, so we just write it here. We know that this is the derivative of that, so we have to write our cos of the angle 3x multiplying the derivative of g at x, and that is what? 3. So when we do our little algebra, we are going to get 3 cos 3x, and this is the derivative of this very function. We take our next example. So we have to find the derivative of the function h at x, which is equal to cos of 4x, cos of 4x. So we first have to identify our outside function, and we know that our outside function is cos. So we let f at g at x be equal to cos, and then we have our angle 4x, and then we let our g be equal to what? The inside function, that is 4x. So when you find the derivative of f at g at x, when we differentiate cos, what are we getting? We get negative sine, and then we have our 4x, and after that we differentiate the inside function, which is what? 4. So we are getting g prime at x. When we differentiate 4x, we are getting 4. So the next thing that we are going to do is to just substitute the derivative into the chain rule formula, and we know that the chain rule formula is given as this. So we are going straight. So we have our derivative h prime at x of this wave function. So we know that our f prime at g at x, which is this, we are using this chain rule formula. Okay. So we are getting negative sine of 4x multiplying the derivative of what? The inside function, and that is what? 4. So at the end, we are getting negative 4 sine of what? 4x, and this becomes the derivative of this very function. Very simple. So how would you find the derivative of this very function? So we can see that we have a function of cos and then a function of what? S squared, a function inside another function. So we can apply the chain rule. So we first have to identify our outside function. So we can say that our outside function is cos. Okay, so we write our cos of what? S squared, and then our inside function, we call it g at x, and that is what? our x squared. So the next thing is we find the derivative of this outside and then inside function. So we are getting f prime at g at x. When we differentiate cos, what do we get? We are still getting negative sign, and then we add our x squared to it, and then after that we find the derivative of the inside function. We are getting, when we differentiate x squared, we get what? 2x. So we just substitute these derivatives into the chain rule formula. So at the end we are having our derivative of the function y at x. We are getting negative sign of x squared multiplying the inside function, that is what? 2x. So at the end we are having minus 2x and then sine of what? X squared, and this becomes the derivative of this very function. So in short, to find the derivative of functions of this trig functions of this nature, you just have to differentiate the outside function and then multiply it by derivative of the inside function. Very, very simple. So how are we going to find the derivative of this very function sec2x? Sec2x. So what we are going to do is to differentiate the outside function and then multiply it by the derivative of the inside function. And we know that this is sec. So when we differentiate sec, so we write our derivative of y, which is y prime at x, is given us, when we differentiate sec, we get what? Sec x. But here we have the angle to be what? 2x. So we have sec 2x and then what? Tan 2x. Then after that we multiply it by the derivative of the inside function, which is what? 2x. Good. So we know that we have sec 2x tan 2x, and then when we differentiate 2x, what we get? We get 2. Then our last step is going to be like multiplying the 2 by sec 2x tan 2x, and then we are done. So we have 2 sec 2x tan 2x, and this is the derivative of this very function. We take more examples. In this example, to find the derivative, we are going to differentiate each of the function term-wise. So when we take tan 3x, we differentiate it. When we take 5 sin x, we differentiate that. So we are just going to do just that. Good. So we can say that our derivative h prime at x, we differentiate each of these function term-wise. So we have the derivative of tan 3x, and then we have 5 is a constant, so we can just factor it out, and then we take the derivative of sine of the angle x. Good. Now tan 3x, okay, we can apply the chain rule. We differentiate the outside function, then we multiply it by the derivative of the inside function. So we know that our outside function is tan. Now when we differentiate tan, what do we get? We get sec squared. So when we differentiate tan, we are getting sec squared, but we have the argument to be 3x. We add it to it, then we multiply it by the derivative of the inside function. So it means we are going to differentiate the inside function, which is what? 3x. Good. Then we have our 5. When we differentiate sine, we get what? Cos of the angle x. Now we have already differentiated this, so we have sec squared 3x, and then when we differentiate 3x, we are getting 3, and then we have our 5 cos x. So finally we have 3 sec squared 3x, and then we have 5 cos x, and this becomes the derivative of this very function. So we have our next example. Now we can see that with this particular example, we are having two functions multiplying. That is 2x cubed and then sine x. They are multiplying. So to find this, we have to apply the product rule. Okay. So in applying the product rule, we know that we keep the first function, which is what? 2x cubed, and then we find the derivative of what? Sine x. And then we add it to the derivative of sine x, and then we keep what? The first function. So that's what we are going to do. So we know that our derivative h prime at x is given as, we differentiate 2x cubed sine x, and then we take the derivative of what? 5. And we know that this is a product of two functions, so we treat them as such. So it says that we keep the first function. Those who have forgotten, kindly go back and then watch my video on product of what? Two functions, or applying the product rule in solving questions. You can get a clue on how to solve it. So we go straight. So we keep the first function, which is what? 2x cubed, then we multiply it by the derivative of the second function, that is sine of the angle x, then plus, we keep the second function, which is sine x, multiplied by the derivative of the first function, 2x cubed. And then when we differentiate 5, we are getting what? 0. That the derivative of a constant is 0. So we have our 2x cubed. When we differentiate sine, we get what? Cos. And then we have our sine x. When we differentiate 2x cubed, applying the power rule, we are going to get 6x squared. So we finally we are going to get our 2x cubed cos x plus 6x squared sine x, and this becomes the derivative of this very function. So how are we going to find the derivative of this particular trig function? So we have two functions multiplying. We have the function of x cubed and the function of sine 5x. So we are going to apply the product rule. So the product rule says that our derivative y prime at x, we differentiate x cubed multiplying sine of what? 5x. So applying the product rule, we are going to get, so we keep the first function, which is what? x cubed, and then multiplied by the derivative of the second function, that is sine of what? 5x, then plus, we keep sine x, sine 5x, sorry, and then we differentiate the first function, that is what? S cubed. So we have our s cubed here. Now looking at the derivative of sine 5x, we can apply the chain rule here for us to get the derivative of sine 5x. So let's bring our macho bracket here. Now when we differentiate sine, we get what? We get cos. So we have cos of 5x, and then we multiply it by the derivative of the inside function, that is what? 5x. Then we have our sine 5x. Then we find the derivative of what? S cubed. So when we find the derivative of that, we are going to get 3x squared, applying the power rule. So we have s cubed, our macho bracket, we have cos of 5x, and then when we differentiate 5x, we are getting what? 5. And then we have, let's rearrange this. We can rewrite it in the form of 3x squared sine 5x. Now with this one too, they are all multiplied, so we can rearrange it. So we can get 5x cubed cos of what? 5x, and then we have plus 3x squared sine 5x, and this is the derivative of this particular question. So I'll give you a try work. You try your hands on it and you make sure you write your answer in the comment section. Don't forget to subscribe to this very channel for more updates. So this is the question. You try your hands on it. You make sure you write your answer in the comment section. Thanks for watching. Bye bye.